Welcome, everyone. So my name is Anastasia Ryasanova, and I'm a coordinator of the Treesearch Research Infrastructure. And let me tell you first, really quickly, what is Treesearch Research Infrastructure? So it's a research platform for the analysis of materials from trees. And it's a very unique activity that we have in Sweden because it's basically the only one for this field. It's currently uniting 9 Swedish universities, 1 research institute, and 1 national laboratory. Through the Treesearch Research Infrastructure, you can get access to the advanced characterization and processing techniques, as well as getting access to the high-end competence data acquisition and in-depth data treatment. Everyone is welcome to apply. From industry and academia, the only requirement that the applicant must be associated to Treesearch. So that means that both the project must be associated and the individual must be associated. And the big benefit that we can also provide through Treesearch, we can provide the financial support. So for all applications where the support is granted, Treesearch will cover the fees for the specialist time. Then also what we do through the Treesearch Research Infrastructure, we organize courses, webinars, different kind of meetings, hands-on training, and we also work with the special interest groups for the specific techniques. So here you can see the map, and you can see that we are located pretty much all over Sweden, and it's LTU, SLU, Mion, Stockholm University, RISE, KTH, Linköping University, Lund University, Chalmers, Karlstad University, and types of techniques, they spread from microscopy, spectroscopy, diffraction, tomography, chemical composition analysis, mechanical testing, interaction methods, rheology, advanced sample preparation, and treatment. So let's take a look in details per node, per university. So competences that we provide at Chalmers, that's SAX-VAX, DLS, SLS, Raman, SEM and SEMFIB, and TM. At Linköping University, it's XPS, UPS, and Swedish Research Laboratory for Printed Electronics. That's what you will hear about today. Then at Luleå University, that's what you have heard already yesterday. That's X-ray tomography and biomass steam pretreatment. And at Luleå University of Technology, we have X-ray tomography, Extruder lab, biomass pretreatment, and fractionation reactors, and that's what Mikael will present today. At Micro University, our competences are in the field of high-resolution electron microscopy, in particular on the focus on SEM and EDS, and then also Raman, AFM, XRF, and advanced sample preparation. At Karlstad University, our specialists working with rheology, and at SLU, it's Biomass Technology Center. At KTH, we provide support with the also electron microscopy, which is SEM, EDS, TEM, including cryogenic conditions, AFM, QCM, FTIR, and also carbohydrate analysis platform. So that's what you have heard a little bit about yesterday, as well as about Stockholm University competences, which are in the field of high-resolution transmission electron microscopy, including in situ diffraction and spectroscopy. At RISE, our colleagues work with SAX-VAX and the NMR, FSP, OTR, WTR, and DMA. And then also Treesearch Research Infrastructure is including also the MAX4, so basically 4 max synchrotron beam line, which should be fully operational from next year. And you can follow this link to check the list of all available infrastructure. We also have categorized it. And if you want to apply, you just go to the application page and you just follow instructions step by step. And you describe your project and then send in your application. If you have any questions, please feel free to email me directly or email infrastructure@treesearch.se. Are there any questions about this part? No? Okay, then silence means that you all have a proper overview of what I just presented to you. So I think with this, it's time for me to welcome Mikael Sjödahl from Luleå University of Technology. Mikael is also a node coordinator at LTU, Treesearch Research Infrastructure, and also professor at LTU. So let me stop sharing the screen and ask Mikael to try to share his slides.
So, thank you, Anastasia.
Yeah.
So, I will present the infrastructure at LTU that is available through the Treesearch network. And there will be 3 systems plus some additional information that could be of potential interest. The first one to be presented is an extruder for manufacturing of composites, and that one is managed by Kristina Oxman's group here at LTU on bio composites. And the other one is a reactor for biotreatment that is managed by Ulrika Roba at biochemical process engineering. And then we have the lab-based micro-tomography system and 3D diffraction imaging that is managed by Fredrik Forsberg in my group at Experimental Mechanics. And I will go into some more detail about what can be done with these equipments and how they contribute to the infrastructure at Treesearch. So this is the extruder equipment. It's you have a number of features with it here. This is a very flexible system, and you can do quite a lot of things with it. It has, like as all extruders, it has like a screw that is used for just pressing the material through it, and you can add a lot of different materials and different fibers structures to it in various places. It's a fairly fast process. You can manufacture these in about a minute. Looking at details, it looks in principle like this. That you have like you add the polymers and or whatever other material you want to use, and then you can choose places where you can add the fibers. One good feature with this system is that you can have a very good dispersion between the fibers. So and also that you have separated the matrix and the fiber places where you add them. You get much less fiber breakages in it. It can look in principle like this when you manufacture, in this case, small pellets. And that's about it. It's available and can be used for many various kinds of manufacturing materials. In addition, they have like Kristina wanted me to show also this lab scale calendaring and blow molding equipment that also is available for anyone that's interested. You basically make films with it. Then the other system that we have is like a biorefinery for biomass fractionation. You can use it to diverse the cellulose mass or biomass into different constituents, and you can see in principle here what it does, like a flow chart. It can use different kinds of feedstock, or that includes cellulose and other type of constituents, and coming from various places. You can have different solvents to it to treat. It's anything from some alcohols to acetones and so on. And you can also change the temperature within some limits. Here is some bit more information about what's coming out from it. But in order to work out the details, you need to get into contact with Ulrika Rova, primarily at Bioprocessing Group. This is how it looks right now. So this is the present reactor. This is a 3.0 reactor. It's rather large, although it fits into a lab. Yeah, so this can be used directly and is available for testing various processes. There is also a project going on that should transfer this into the 4.0 version of it. So, and this will be more of a continuous process, and it can take on larger volumes and being a bit more flexible as it seems. And this is an ongoing process or ongoing project, and is called Biomac. They also have available smaller lab scale reactors of various kinds that can also be used for testing new ideas and so on. But again, for more details, please contact Ulrika. When moving on to the X-ray tomography machine, this is the old tomography machine from the outside that is that is available. This is a tomography machine from Zeiss, and this was the X-Radia 510 Versa Micro-Tomography system. This system has just been updated to the 620 version, which meant exchanging the source to a different kind of source that have a higher flux and should be more stable. And also there is some hardware added to it to manage 3D diffraction tomography. This is how it looks from the inside. You have a source which is the microfocus X-ray source in this case, and then you have a detector on which you can use different objectives, which means that you can image this sample at different magnifications. So anything from like millimeter across to a centimeter across is doable, which means that you can manage the resolution of your sample. We also have an in situ compression tensile loading machine in which you can change the temperature, or you can control the temperature in between -30 to +150 in that range. Which is quite nice for different kinds of applications. Some typical examples. This is not now from wood. This is from a granite block, or at least rock. This is from a Brazilian test equipment or test. You can follow the strain showing up inside this rock because of the compression, and that one is that result is then calculated using volume correlation, basically. This is a typical type of images that you get. This is a modified wood structure. I think in this case the modification is a heat treatment, and then you can follow the microstructure, how things are changing because of that, and you can continuously follow changes during a heat process if you have a heat process on in the machine. This is another nice example. This is a pine seed that we have received from SLU in Umeå, where you can see you can see the details inside the pine seed, and you can even see the small pine inside there that should growing hopefully when planted. Some new features to this tomography machine is the diffraction contrast tomography setup, which is called then LabDCT. I have to say that we haven't really at this point tested it because it was finally installed last week. So we are in the process of testing it out. But in principle, this is a SWOX, which is yes. So it's a diffraction experiment, but in which you just rotate the sample and then you put together the different diffraction outcomes, and it will build up a three-dimensional structure. Since we haven't really tested it yet, this is stolen from another paper that's been published where they have used exactly the same setup. So here you can follow the grain growth in an aluminium alloy during annealing, and you can see how the grains are continuously changing as the process is ongoing. So, but we are thrilled to try to learn more about what this type of equipment can be used for, hopefully together with researchers within Treesearch. And some additional equipment that isn't listed on the Treesearch homepage. This, for example, is a laboratory press that can also be used. It has some special features. And this is also mainly used for making composites. We also have access to a micro DIC, in which you can follow small range over small scale, and this is a commercial system from LaVision. We also have several thermal cameras. Actually, this is one of the newer ones that can also be used for detailed testings. And in connection with DIC, you can also then follow internal structures, how they deform in different temperatures. But that's about it. So if there are any questions, you are free to add them, and I will try to answer.